Welcome to Chem Talk, Breaking Down the Basics series.
Hello, everybody. My name is Julian, and today we will be going over the part one of two videos on quantum numbers. This first video will be going over quantum numbers themselves and the four different quantum numbers. Now, the quantum numbers represent the different possible configurations and placement of electrons within an atom. The bigger an atom, the more electrons, the more possible configurations. Now, first, we have quantum number n, which is our principal quantum number. This represents our energy levels. Now, electrons in an atom are arranged in different energy levels. So, something really small, this is hydrogen, one proton, one electron, only has one electron level. This right here is carbon, six protons, six electrons. This has two energy levels. So these first two electrons are energy level 1. These other electrons, energy level 2. So these guys right here would have an N of 1. These ones out here would have an N of 2. Bigger things can have an N value of 3, 4, 5, 6, 7. You get the idea. The further the electrons are from the nucleus, the higher their energy level, which represents different principal quantum numbers. Next, we have L, which is our angular momentum. Angular momentum is based on our energy level. So the number of angular momentums possible are values from 0 to n minus 1. Now, I want to reiterate real quick. All of these values are going to be integers, so not 1.5, 1.7, just 1, 2, 3. So for something like hydrogen, 0 to n minus 1 is just 0 to 1 minus 1, which is just 0 to 0. So there's only one possible angular momentum, which represents our subshells. So there's only one subshell for hydrogen, which is S. We'll go over that in a later video. For carbon, there are two different energy levels, which means we can go from 0 to 2 minus 1 or 0 to 1. So we have two different angular momentums, 0 or 1. Two different subshells, which is S and P. We'll go over that later as well. Next, we have our magnetic quantum number, which represents the different orbitals within those subshells, the different shapes that electrons will occupy within the subshells. So, for something like hydrogen, we've determined it has an energy level of 1, and then our angular momentum is 0 to n minus 1, which is just 0 to 0. So negative 0 to 0 is just 0. There's only one possible magnetic quantum number for hydrogen. For carbon, these outer electrons are at energy level 2. So there are two different angular momentums, 0 or 1. If we look at something occupying the angular momentum of 1, that means there are different possible magnetic quantum numbers of negative 1, 0, and 1, which represents our three different orbitals within our one subshell, or P subshell. And finally, within each different orbital of the subshell, we can have two electrons, which represents our downspin and our upspin, and we will go over that in a later video. But downspin, we will represent for our electron spin quantum number as a negative half. Upspin is represented as positive half. Now, a couple final things. The Pauli exclusion principle tells us no two electrons can have the same set of quantum numbers. There will always be one of these numbers that is different between them. So for this electron, it could be N2, could be L1, and it could be ML of, let's say, negative 1. And this could be the same. This could also be N2, L1, and ML negative 1. But if that's the case, then the electron spin number would need to be different. So this would have to be negative half, and this would have to be positive half. Those are our quantum numbers. In the next video, we will go over applying them. Thank you so much for watching.
That's a wrap for today's episode of Chem Talk, Breaking Down the Basics series. Thanks for watching. If you enjoyed this video, don't forget to hit that subscribe button. Until next time, keep learning, stay curious, and we'll see you in the next Chem Talk, Breaking Down the Basics episode.